How does your computer or smartphone allow you to watch a YouTube video? The answer is going to be through networking, specifically through the internet. Networking is what makes your computer and servers useful. This is the case also with virtual machines. But exactly how do virtual machines connect to the internet? Well, let me go ahead and tell you. This is B from Tay Talk Tech, and today I'm going to be explaining to you how virtual machine networking works, so stick around. Now, I have a favor to ask. If you like this type of video and you want to see more like it, make sure to subscribe and hit the bell button for notifications. Also, don't forget to give this video a like if you like it. Let me know what you liked, didn't like, or if you have any comments, questions, concerns, or emotional outbursts down in the comments below. And lastly, stick around all the way to the end to get the most out of this video. Let's do this thing. All right, so let's go ahead and just talk about what we're going to be covering in this video. So this video is going to focus on networking on Linux systems using the libvirt API, but the concepts will apply to all virtual machine networking because these are going to be the most basic types of networks that are going to be set up on those. Now, essentially, when we're talking about a computer network, what a computer network is, it's a network of servers, computers, devices that all come together to be able to communicate. Now, the largest network that you're probably familiar with is going to be the internet, because that's a lot of other networks that are combined into a much larger network, and then stuff is routed throughout those to get to the places that they want. And essentially what happens is, when we use the intro to talk about, when we talked about YouTube videos, is your computer is going to make that request to YouTube, and then over the internet, which is just a large network, and it's going to go ahead and say, hey, YouTube, give me this video. YouTube's going to say sure, and it's going to go ahead and send it back to you. That is routing in its most basic form. Now, when we talk about the devices that make up networks, besides servers, smartphones, other smart devices, other Internet of Things devices, servers, all that good stuff. The other most basic devices that help make that possible are going to be routers and switches. Now, in their most basic explanation, a router routes traffic between networks, and a switch will route traffic within a network. Now, there are switches that will also route traffic between networks, but that's not the focus of this video, so we're not going to get into that. Now, when we're talking about an actual device, these devices, the most common interaction that you will have with these is the device that you get from your internet service provider. At least here in the United States, in my experience, these are all going to be in one single device. You will have a router, you will have a switch, and you'll also have an access point. So an access point is another device that's used for connecting networks, but that's going to be a wireless network, and those are all built in, and those antennas are coming off. Those are going to be connected to your wireless access point to be able to go ahead and get signal throughout your premises and things like that. The ports on there are going to be the switch, and then the actual routing capabilities are built into the actual device itself. It's an all-in-one. It simplifies management for most homeowners and makes your life easier. So let's go ahead and look at a simple topology using my own personal home network. So let me go ahead and take my face off of here. All right, here we go. So I use Unify for all my networking needs, and I've got a pretty simple network as of right now. I do plan on, making this network a little bit more, little less linear. I want to go ahead and definitely be able to scale it out and have a few more layers to it in the future. So yeah, we have our device here. This gateway right here is going to be the actual router that is routing the traffic between me, the internet, all the other networks that are out there available. This is my primary switch, which is where majority of the network is managed through, but we also do have a smaller switch here. Now we can see here that we've got quite a few devices that are connected. We have these right here that are connected directly to the switch. We have the test server, we have the Raspberry Pi 4, we have a device that just kind of checked out there, which does happen from time to time. It's probably not broadcasting anything, it's just chilling. We also have my MacBook Pro here that's actually running through the small switch. Then we have our access point, which is handling all the wireless clients, which we have my MacBook is actually also connected over Wi-Fi, my printer, my iPhone, and my iPad. So this is a basic, simple network topology. Again, if this was, the typical device that you get from a internet service provider, it's going to have all of these devices in a single device. So just keep that in mind. But I wanted to kind of give you an idea of what a network looks like. So let's go ahead and now start talking about let's go ahead and start talking about virtual machine networking. So again, this is going to apply to any type of, any type of application you're using. If you're using VirtualBox, KVM, any of the other ones are going to, these basic concepts are going to apply because they're going to be using certain types of networks. Now, the default network, at least in libvirt terms, KVM world, is going to be the mode is going to be a NAT setup. Now, what is NAT? NAT stands for Network Address Translation, and essentially what's going to happen is there's going to be a network that's going to be set up by a virtual switch on the device, which is this guy right here. And we can see here that these are going to have their own special network. That's just for the virtual machines. Well, what's going to happen is that this traffic is going to be address translated to by the actual host server, and it's going to go ahead and, well, actually it's going to be applied here between the server and the host server. And then all of the traffic that's coming from these virtual machines is going to look like it's actually coming directly from the host itself. So if you pull the actual packets, you will be able to go ahead and see that's all coming from the host server. Now, keep in mind that there are ways to be able to go ahead and tell which machine's coming from. We're not getting into that because that's a whole complex thing, and there's a lot more to it. This is just really a simplified version of everything. But yeah, so basically what it's going to do is it's going to go ahead and translate these so they can access the internet, and then when it comes back to the host server, it's going to be like, oh, yep, this one goes to 192.168.122.210, and then maybe in this other packet goes to 192.168.122.20, and this again is the actual default setup. And as it says here, is all communications system outside of the host appears to come from the host IP address. So let's go ahead and go to the next slide here. Now, the next version is going to be a routed network. And what this routed network is going to do is it's going to basically put the virtual machine on your home network. Now, the host itself acts as a router, letting the outside world communicate with the virtual machines through its Ethernet interface. So what's going to happen here is you're going to you're going to be putting it on your network. And I've actually done a video on actually adding a virtual machine in KVM to your home network, and that's essentially what we did when we did that. Is we added it to that network versus the default NAT network, because we hadn't specified when we set that virtual machine up, it would have defaulted to the NAT. But here, I want to go ahead and have access to those on my home network, so that's why we used this approach. So essentially what's happening is that switch is still here, but the actual host server itself is acting as a router, and it'll allow these machines to interact with your home network in the same way that any other device will. And they're able to get DHCP addresses, which is just the automatic assigning of addresses, as well as DNS services directly from your like the actual host server is acting as a router, but it's actually the default gateway. So if we go back to my network, the example is that the gateway router, it's actually acting as the actual gateway for these devices as well. So all right, so let's go ahead and talk about the next one, which is going to be a isolated network. So essentially what this does is this allows you to keep these virtual machines from accessing the internet at all, but they will be accessing their own personal network. So this is great when you're testing different scenarios. Maybe you're setting up like a hacking lab or a security lab or something like that, and you want to go ahead and make sure that nothing crazy happens outside on your home network or gets out to the internet. That's when you can go ahead and utilize this one right here. And essentially this server is acting. I'm sorry. This virtual switch is still acting on and managing this little local network for the virtual machines, but it's in an isolated mode. So, and it's just like with these other ones, here, it's acting in a routed mode. And here, if we go back to the previous one, it's acting in NAT mode. See that this virtual switch is probably one of the more important things for the actual virtual network, because it's going to be managing that virtual network, and making sure that these guys can communicate, through the host server in whatever way it needs to, or not connecting with the host server and all that good stuff. So, because there are reasons that you want hosts to be isolated, especially if it's, maybe something that manages, like a virtual machine that manages, I don't know, like some kind of manufacturing equipment or something like that. But Yeah, so let's go ahead and get back to DNS and DHCP. So this is all going, DNS and DHCP are going to be handled by the virtual switch, especially like if we're looking at, something in NAT mode or in isolated mode. Now this changes when we start talking about a routed one, because it's still going to be using that, it's still going to be going through that switch, but it's basically going directly onto the local network, and it's going to go through those channels that the local network goes through for DHCP and DNS. And if you're not familiar with DNS, that's the domain name services, where MAC addresses and IP addresses, host names and IP addresses are resolved, and then DHCP is that's how hosts automatically get an IP address on a local network. So now let's just talk briefly about the libvirt default configuration. So libvirt's default configuration is going to be in NAT mode, and that's the same thing for a lot of them. If I remember correctly, I think it's been a little while since I've used VirtualBox, but VirtualBox is the same way. VirtualBox will go ahead and default to NAT mode, but you can go ahead and set all these other different modes and things like that. And keep in mind, the platform that you're using for managing your virtual machines will always have different types of other network configurations you can do, but we're not getting into anything other than the ones that we're already talking about here. So this is what's going on here. So here's your actual virtual machines right here. Here's that virtual switch. You're actually going to see an interface called VIR-BR0, which is actually that switch, and is going to be handling all these different services for these virtual machines. And again, like this is when we're talking about NAT mode. This is what's going on here. Now, there's another, like when you're talking about doing a routed network, you don't see it in this picture here, but there's, at least on these Linux systems, and it's probably, I've got to go back and look. I'm sure it's the same thing on, like VirtualBox and all that stuff, is that there's a bridge interface that allows it to go out over the over the network card of the actual host system. So that would, again, so any routed is always going to be handled on the actual local area network, and this right here is going to be the NAT mode. So yeah, and I actually did a video on setting up a virtual machine on a local area network, as well as setting up the bridge to go ahead and make that connection happen. So check out those videos if you want to know more about those. But yeah, so this is essentially what's happening here in a Linux host system, virtualization host server. As here's the actual network stack, all that stuff, and here's going to be the actual Ethernet port, which in this case is going to be ETH0. Now, one thing you'll want to keep in mind is that you can't do, at least currently as things stand with libvirt and all that and KVM, is you can't set up a routed network over a Wi-Fi interface. So keep in mind that those will need to be done over an Ethernet interface directly. So keep that in mind. Now, networking is one of those things that appears overwhelming at the onset, but once you understand it, it's actually pretty simple. I only briefly mentioned libvirt and do plan on doing a video on it more in depth in the future, so make sure you're subscribed to not miss that one. Now, make sure you check out making sure you check out the other videos in my Linux virtualization series, and if you're caught up on those, make sure to check out this other video from my channel as well. Remember, mistakes make you better, so keep on making them. Thank you so much for watching my video, and have the greatest of days.